Hi everyone! Today I will be presenting on artificial turf fields and their effect on the environment. The study I found focused on energy usage and greenhouse gas emissions from the installation, maintenance, and removal of turf fields. As an athletic trainer, I spend a lot of time on turf fields educating coaches and athletes on health risks associated with playing on turf fields. I personally wanted to find literature and research that talked about the fields and their effect on the environment, as opposed to the fields and their effect on human health. Some abbreviations used in this study were as followed. GHG was defined as greenhouse gas. Greenhouse gas emissions were measured throughout the study at various construction sites. RT, TPE, EPDM, and REPDM were all substances used in the creation of layers in the artificial turf fields. Specifically, they were used for the shock absorption layers and the infill layers that comprise the fields. RT, or recycled tires, TPE were thermoplastic elastomers, EPDM were ethylene propylene diene monomers, and REPDMs were recycled ethylene propylene diene monomers. There were two studies conducted, or assessments, I should say, conducted during this study, the LCA and the RA. The LCA was a life cycle assessment that measured the greenhouse gas emissions and the energy expenditure during construction. RAs, or risk assessments, were conducted for chemical exposures that happened during construction or after construction. DOCs referred to dissolved organic compounds or compounds that could be found within the turf fields after removal. GJ was the abbreviation for gigajoule, which was the unit of measurement for energy expenditure. And SVOC were semi-volatile organic compounds. That is in reference to the chemicals that were found during the risk assessment. What was the problem? The study focused on the creation and installation and removal of artificial turf fields. So their problem was, what effect does all this construction have on its surrounding environments? And to figure out the solution to this problem, they wanted to look at the energy usage, the greenhouse gas emissions, and the metals and organic substances from the construction. A little bit more about the study. So the study focused on the production of artificial turf fields in Sweden and Norway. Artificial turf fields are incredibly prevalent over in Sweden and Norway. Almost every high school and every college has a turf field. This was a retrospective study that looked at fields that had already been created, fields that had already been removed, or fields that were in the process of construction or removal. By polling from different literature and reports, they were able to collect all of the information and data used in this study. Some of that data was comprised of vehicle usage, construction machine usage, energy usage, and greenhouse gas emissions, and the infill materials used in construction, maintenance, or removal of those artificial turf fields. These research objectives were taken straight out of the text. The research objectives were to quantify the life cycle use and greenhouse gas emissions for the construction, maintenance, and removal of artificial turf fields. Their second objective was to analyze the potential release of metals and semi-volatile organic compounds from the infills into the water. This focused on the surrounding environment and anything that could really be affected, not just there at the field, but water systems and surrounding neighborhoods that could also be affected by the installation of these fields or the removal of these fields. The study gave specific schematics on a field that was constructed during the study and was measured and analyzed within this study. I did not provide the specific schematics. I provided a brief breakdown of how a artificial field is constructed. So first, they excavate an allotted amount of soil for the inlay of the field. This soil is then transported in a vehicle to an off-site location to be disposed of, reused, whatever the construction company or contractors have decided to do with that soil. This is one contributor to the excessive amounts of greenhouse gas emissions in construction projects. The second step is to lay the PVC pipe for the drainage to the field. The herringbone pattern is just the simple setup that they use to allow for runoff on the field and allow that field to drain properly. Once the drainage is complete and sealed, they're going to seal off that drainage level. Can you guess what they're going to seal it off with? They're going to seal it off with the rock and soil that's already been transported away from the site. This now requires another transportation to bring more soil and more gravel and more rocks to seal off this drainage level. The second level after the drainage level would be the shock absorption layer. This is usually made up of the recycled tires, those TPEs or the EPDMs, whichever the construction company has already allotted for this field. After the shock layer is installed, the artificial turf mat is rolled out manually and glued together. This glue is another example of those chemical exposures that could possibly happen. This is a two-component adhesive, and its usage in the field is at almost that top superficial layer. So just another component that could possibly be a potential risk or hazard for the environment and human health. After the turf mat has been installed, the infill sand and infill layer of either RTs, EPDMs, TPEs, or REPDMs is installed. After that is installed, the lines are painted on. Again, the lines and the paint, those are chemical hazards for the artificial turf fields, not just to human health, but also through runoff and any excess used during that project. Methodology. As I spoke of before, the life cycle assessment was used to measure the energy usage and the greenhouse emissions. It also measured the sustainability of those infill materials used, so whether the recycled tires or the TPEs were more energy efficient than the other. The methodology included collecting subjective and objective measures. This pertains to subjective meaning word of mouth, and objective meaning actual tangible things they could measure, like the energy usage and the greenhouse gas emissions. These measurements were actually received from previous literature reports, as I said. They were also received from the contractors and from the artificial turf owners themselves, as well as the Swedish Football Association. They were all very compliant in providing schematics and materials, timelines, and machinery usage during these construction projects. So what did they find? They found that transportation during construction had an incredibly large impact on the total energy usage of greenhouse gas emissions. The total energy usage found in this study was 5.9 gigajoules. The greenhouse gas emission was equivalent to 527 tons of CO2 equivalents. This was broken up through those three stages, that construction, removal, and maintenance. And as you can see from the breakdown below, that construction did make up the most of those greenhouse gas emissions. So conclusions. They wanted the readers to be those installing, those thinking about installing, and those involved in the decision making for installation or removal of artificial turf fields. They wanted to consider all types of infill and their associated energy usage. TPEs and EPDMs were the higher energy usage. They used more energy than using the recycled materials such as the REPDMs and the RTs. They concluded that transportation of supplies was the greatest contributor to energy usage and greenhouse gas emissions. Like we talked about before, that transportation of soil and rocks to the offsite location to be disposed of, reused, whatever the contractor has decided, as opposed to reusing that soil and rock material on site when they had to re-level or seal off the specific layers. They also concluded that chemicals used during construction, such as the glue, the paint, different chemicals or metals that could be found in the recycled materials, could leach substances to the recipient. Those recipients would be neighboring communities, those water sources, animals, anything in that immediate surrounding environment. The practical application, in the US there's more than 11,000 artificial turf fields, and that number is quickly climbing. As I said before, high schools, middle schools, and colleges are moving to these artificial fields because of their look, their effect on injuries, and their effect on the play of the game. Even natural grass fields are being converted into hybrid turf and grass fields to increase shock absorption, and the prevalence of artificial playing fields is growing, so the long-term effects need to be considered before installing, and this study and application allows for that information such as chemical exposure and construction usage to be known and to open the door for more research on this subject. So in summary, while artificial turf fields may be great for sports play and nicer in appearance than natural grass fields, their effect on the environment needs to be taken into account before installation. Construction of an artificial turf field uses about 5.9 gigajoules and 527 ton CO2 equivalents. There are energy efficient ways of constructing and maintaining a turf field, and they should be taken into account when installing, removing, or constructing. These are my references: the analysis of energy use and emissions of greenhouse gases, metals, and organic substances from construction materials used for artificial turf, and also the new artificial turf design improves safety.